Welcome to Spaceverse, your portal to cosmic adventures. With a time elapsed of only 200 million years after the Big Bang, Webb may have just discovered the galaxies that are the farthest away that have ever been seen, so setting a new record. These galaxies that have long since vanished are causing our long-held ideas about the early universe to be called into question and are changing our knowledge of the evolution of the universe. In this video, cutting-edge science and technology will be utilized to provide an explanation of how these galaxies were discovered, what led to the Webb research, and how they compare to other galaxies that Webb discovered in more distant locations. So let's not waste any time and dive right in. The discovery of 5 possible galaxies by Webb, which may have originated as recently as 200 million years after the Big Bang, is a significant achievement in the field of astronomy. Not only is this astounding, but it also indicates that we are getting closer than we have ever been before to witnessing the Big Bang. The first known galaxy, JWST 14-0, was discovered even earlier, roughly 280 million years after the Big Bang. This discovery was made around the same time. These galaxies, which have redshift values ranging from Z=16 to Z=18, are among the oldest and most distant objects that we have yet to witness. Let me tell you about redshift. In this context, it is an essential element. The redshift is a measure that indicates the degree to which the wavelength of light has been stretched as a result of the expansion of the cosmos. We are able to get a peek of what the galaxy looked like while it was billions of years ago from a greater distance than when it was closer to Earth. This is made possible by increasing the redshift. The models that are now in use for galaxies suggest that the process of galaxy creation and evolution should take a very long time, hundreds of millions of years. On the other hand, judging by their brightness and level of maturity, these galaxies appear to have developed at a much faster rate than was anticipated. We are approaching the first generation of galaxies because we are left with only around 150 million years to form these galaxies, said Dr. Hakim Atek, who is affiliated with the Paris Institute of Astrophysics. The evidence comes from the GLIMPSE research, which utilized some of Webb's most profound observations to this point in time. These distant galaxies are providing astronomers with the opportunity to gain vital information about the Big Bang by allowing them to catch the weak light that emanates from them. It is clear from this that we are not only increasing our technological skills, but also broadening the boundaries of our understanding regarding the evolution of the universe. These galaxies, in addition to throwing light on the early universe, also provide light on the reionization epoch, which is the time when the intergalactic medium was ionized by the first stars and galaxies. By studying this time period, one can gain insight into the beginnings of the first structures in the cosmos. It is comparable to the coming of age of the universe. You might be wondering how Webb was able to locate galaxies that were so faint and so far away. The information that is required can be obtained from the observations of gravitational lensing. Albert Einstein predicted the occurrence of this phenomena in his theory of general relativity. It takes place when a huge object, such a cluster of galaxies, causes the fabric of space-time to stretch, which in turn causes the light from things behind it to be distorted and magnified. For this particular experiment, the James Webb Space Telescope utilized the massive Abell 1063 galaxy cluster as natural cosmic magnifying glass, a phenomenon known as gravitational lensing. This galaxy cluster, with its immense gravitational field, acts as a lens that bends, amplifies, and intensifies the light from galaxies positioned far behind it. This extraordinary effect allows astronomers to observe distant and faint galaxies that would otherwise remain invisible, unlocking a clearer view into the early universe. Gravitational lensing has allowed us to find so many galaxies at high redshifts in the same field, said Vasily Kokorev, a professor at the University of Texas, emphasizing the critical importance of this technique in modern astrophysics. By leveraging this natural phenomenon, researchers can explore galaxies formed during the universe's infancy, shedding light on the conditions and processes that shape the cosmos as we know it today. This approach is not just a tool for discovery, but a bridge to understanding the origins and evolution of the universe. Having said that, this strategy does have some drawbacks. However, in order for it to function properly, it is necessary to align massive foreground objects with distant background galaxies. As a result of the lensing effect, which can skew observations of these galaxies, efforts to discern the real structures and properties of these galaxies are further complicated. It doesn't matter what the circumstances are, the fact that the strategy increases our capacity for observation makes it significant. It not only helps us comprehend the early universe better than we did before, but it also offers up new avenues for inquiry into the early universe. There is a need for additional discussion around JADE's GSZ 14-0. The discovery of this galaxy, which has a redshift of Z equal 14.2, indicates that it was discovered approximately 280 million years after the Big Bang. This galaxy exhibited traits that point to rapid creation and enormous luminosity, which throw doubt on the mainstream model of galaxy development. These characteristics are consistent with the most recent discoveries which have been made. It was discovered by the JWST Advanced Deep Extragalactic Survey, which was tasked with the objective of gaining increased knowledge about the early universe. This galaxy is distinguished by its incredible luminosity, which is the defining characteristic that helps to explain its exceptionally rapid pace of star formation. This kind of success in star formation drives investigations into the mechanisms that are driving the evolution of early galaxies, which suggests that the early universe may have been more favorable to the expansion of galaxies than was previously thought. This observation is accompanied by other bright galaxies that were identified by Webb at redshifts ranging from 10 to 13. These galaxies demonstrate a surprisingly high number of early galaxies that are creating stars at rapid rates. The discovery of CEERS 93316, a galaxy that emerged approximately 235 million years after the Big Bang, stands as one of the most groundbreaking findings made by the James Webb Space Telescope. This remarkable achievement was made possible by the Cosmic Evolution Early Release Science (CEERS) program, which is dedicated to uncovering the earliest galaxies and understanding the universe's infancy. CEERS 93316, with an astonishingly high redshift of Z equals 16.4, is considered one of the oldest known galaxies, providing an invaluable glimpse into a time when the universe was in its formative stages. What makes CEERS 93316 particularly extraordinary is its prodigious rate of star formation, which is unparalleled when compared to other galaxies from this early epoch. Its brightness serves as compelling evidence of its origin during a period of intense starburst activity, a time when the universe's conditions were ideal for the rapid formation of stars. This era, marked by high-density regions of gas and intense gravitational interactions, was crucial for the creation of the first generations of stars and galaxies. The study of CEERS 93316 not only highlights the unique environment of the early universe, but also underscores the transformative role of Webb's advanced capabilities in revolutionizing our understanding of cosmic history. By revealing the properties of galaxies like CEERS 93316, scientists can piece together the puzzle of how the earliest structures in the universe formed, evolved, and set the stage for the galaxies we observe today. These new discoveries offer additional evidence that early universe galaxies would have undergone fast expansion and evolution. This reveals a universe that was far more dynamic and active than was previously believed to have been the case. The future holds a great deal of potential, and it can be seen on the horizon. The results of the Webb Space Telescope are expected to be supplemented with new data by future projects such as the Extremely Large Telescope (ELT) and the Nancy Grace Roman Space Telescope. These projects are expected to improve spectroscopic follows, validate redshift values, and delve farther into the lowest light sources. According to the scientist Dr. Kokarev, future projects will enhance our ability to detect even earlier and fainter galaxies, although these would be extremely hard to detect. Thanks for exploring the universe with us today on Spaceverse. If you enjoyed this journey into the distant reaches of the cosmos, don't forget to hit that like button and subscribe to our channel for more awe-inspiring space discoveries.